Hello students, my name is Sumit Sagar Hota. I am a PMRF PhD scholar IIT Palakkad. Today we will discuss lecture number 41 to lecture number 45 by Professor Ashok Desar IIT Kanpur of the subject Introduction to Airbreathing and Propulsion. This is the week 9 of the live discussion section. The prerequisite for this section is you have to watch lecture 41 to lecture 45 by Professor Ashok Desar. Sorry, here it is the week 9. Okay, so the first question, the Navier-Stokes equation is conservation of dash. Okay, the Navier-Stokes equation is the conservation of momentum. Okay, Navier-Stokes equation is the conservation of momentum. So answer is B. The centrifugal compressor is an dash. Okay, the centrifugal compressor works on which kind of process? Okay, so okay, the centrifugal compressor, on some circumstances it can be reversible. Okay, under some circumstances the centrifugal compressor is go through or is act like a reversible processes. Okay, in centrifugal compressor the flow is what? Okay, so obviously for centrifugal compressor the flow is always radial. Okay, radial flow. Okay, centrifugal compressor radial flow. Okay, in centrifugal compressor Centrifugal energy present in the gas is utilized to dash. Obviously, the centrifugal energy is utilized to compress. Okay. Centrifugal energy okay to do work. Okay, and what is the work? Compress. Okay. The centrifugal compressor delivers dash flow capacity. Okay, the flow capacity of the centrifugal compressor is always very low. Okay, for action it may be high. Okay. Flow capacity low. Rotating speed of a centrifugal compressor is dash function of diameter to be maintained. It's inversely proportional. Okay. What is rotating speed formula? ROT is inversely proportional to the diameter. Okay. Okay. Okay, so next question. Dash has large change in inlet to exit radius when compared to centrifugal compressor. Okay. Okay, so the answer is A. Dash has a large change in inlet to exit radius when compared to centrifugal compressor. Answer is axial compressor. So delta R of axial compressor is greater than delta R of what? Centrifugal compressor. Okay. The first part in both centrifugal compression and axial compressor are what? Similar. Obviously, it is a true statement. Okay. Okay. Next question. The centrifugal compressor dash energy by increasing the radius, whereas centrifugal fan decreases the energy. Okay. Answer is B. Decrease. Centrifugal compressor decreases the energy by increasing the radius, where centrifugal fan decreases the energy. Okay. Okay, so energy of centrifugal compressor is inversely proportional to okay. So energy of centrifugal compressor or fan is inversely proportional to the radius of centrifugal compressor or fan. Okay. That means if energy increasing, that means the centrifugal, if the radius is increasing, the energy will what? Energy should decrease. So B is the answer. The centrifugal compressor increases the density of fluid more than dash. Okay. Answer is C. Density increase 5% for what? Centrifugal compressor. Okay. The centrifugal fan has a relative fluid velocity is dash. Okay. Okay. It's obviously centrifugal fan. Mach number less than 0.3. Okay. So answer is C. What is the pressure coefficient of a centrifugal compressor and derive that? Okay. Okay. So what is the psi p? Okay, so first of all, some expression you should know. Psi p. But what is the pressure coefficient of centrifugal compression? Derive that. Okay, so what is pressure coefficient? Okay, let's represent it by psi p. Okay, so we know psi p is equal to 1 minus phi 2 cot beta 2. Okay, and what is phi 2? Flow coefficient. And what is beta 2? Blade angle at outlet. Okay. Okay, this is the to prove this. Okay. Okay, so let's write down all expressions. What is psi p's expression? What is psi p? Is equal to h divided by u2 square divided by g. And what is h? H is equal to your I write down here pressure coefficient. Okay, H divided by U2 square by G. What is H? Heat developed is equal to V omega 2 U2 minus V omega 1 U1 divided by Z. Okay. For centrifugal compressor, what are the conditions? VW1 or V omega 1 0 and V1 is equal to VF1. Okay. Now the H will reduce to H equal to V omega 2 U2 divided by Z. Okay. And what is V omega 2? V omega 2 equal to U2 minus VF2 cot beta 2. Okay. Now substitute V omega 2 here. What is your H? U2 minus VF2 cot beta 2 U2 divided by Z. Okay. Now you have H, then substitute in. Then what will be your psi P? Psi P equal to H divided by U2 square by G. Okay. So first write down what is H. U2 minus BF2 cot beta 2 U2 divided by Z U2 square by Z. Okay, this get cancelled. Is equal to U2 minus VF2 cot beta 2 divided by U2. Okay. Implies psi P is equal to 1 minus Vf2 by U2 cot beta 2. And what is Vf2 by U2? It's your what? Phi 2 flow coefficient. Hence proved. Okay. Next question. Okay. In a double-sided centrifugal compressor, the following data are given. Overall diameter, okay. In a double-sided centrifugal compressor, the following data are given. Overall diameter of impeller 50 cm, eye root diameter 15 cm, eye tip diameter 30 cm, RPM 15,000, inlet total head temperature 295 Kelvin, power input factor 1.04, total mass flow 18 kg per second, total head isentropic efficiency 78%, slip factor 0.9. Then assume that the velocity of air at inlet is 150 meter per second and is axial and remains constant across the eye annulus. Find the total head pressure ratio, the pressure required to drive the compressor, and the inlet angle of vane at the root and tip of the impeller eye. Draw TH diagram and velocity triangle. Okay. Okay. So to solve this question, first we have to draw the velocity triangle. This is your U2. Beta V2 VR2 phi BF2 BW2 BR1 B1 U1 theta okay. So then now we have to write down what are the things given. D2 30 centimeter. How D2? The air tip diameter 30 centimeter. So D2 here 30 centimeter. D1 15 centimeter. Air root diameter 15 centimeter. RPM 15,000. So N is equal to 15,000 RPM. Then m dot 80 kg per second. And inlet temperature 295 Kelvin. T1 inlet temperature 295 Kelvin. Then total head isentropic efficiency 78%. Then what is power input factor? The power input factor given as 1.04 and Yes, slip factor 0.9. Okay, power input factor 5W 1.04, slip factor 0.9. Okay, these are the things given. Okay, one more thing I think given is your velocity. Yes, assume that the velocity of air at the inlet is 150 meter per second and is axial and remains constant across the eye annulus. Okay, what does it mean? It means that V1 which is the inlet velocity is same throughout the annulus, that is Vf1 is equal to Vf2 equal to 150 meter per second. Okay, okay, so now what we do, now we draw the TS diagram given, done. Now we have to go for solution. Okay, so for that we draw the TS diagram. We have to only draw for the what? Compressor. Okay, no need to draw full TS diagram. Okay, for centrifugal compressor only 1 to 2 is required, for the TS diagram is only required. So for this kind of question only you draw up to 1 to 2. So this is 1, this is 2s, and this is your 2. Okay, so this is your the case. Now what is T2s by T1? The T2s by T1 is equal to Rp gamma minus 1 by gamma. What is U2? Pi D2n by 60 is equal to what? Pi into D2 is your 0.3, n is your 15,000. Divided by 60. So when you solve, you get U2 as 235.5 meter per second. Okay. So that means now you have all the values for finding power required to drive the compressor. P equal to m dot phi s phi w u2 square, okay, is equal to what? M dot given 18, phi s 0.9, phi w 1.04, u2 square 235.5 whole square. So when you solve it, you get the power required to drive the compressor as 0.94 megawatt. Okay. So this is the answer of your what? Second bit. Okay. So again we know one thing, P is equal to MCP into T2 minus T1. Okay. So now convert in terms of kilowatt and substitute all the values. M.18 CP 1.005 kilojoule per kg Kelvin, 1.005. T2 not given, we have to find out. T1 295, just solve it, get T2 was 347 Kelvin. Okay, so now you get the T2. Now how you can relate T2S and T2? Through the isentropic efficiency. Okay, so isentropic efficiency is equal to 0.78 given is equal to T2S minus T1 divided by T2 minus T1. Okay, so T2S we don't know what is T2S, so T2S we need to find out. T2S is minus T2S is equal to what is T1 295 plus 0.78 T2, what is T2 347, what is T1 295. Okay, so when you solve it you get T2S as 335.56 Kelvin. Okay, now we have what? T2S, T2 and T1. Okay, that means you can now calculate what? Pressure ratio, which asked in the first bit of the question. Okay, in the question we already found out the power required to drive the compressor. This is done. Now we are finding total held pressure ratio, or we are now finding the pressure ratio. Okay, TS diagram and the velocity triangle, everything is done now. Okay, power ratio we are now going to find out. Okay, then we go for the third bit. Okay, now okay, so T2S is the, you see the graph. Okay, so 1 to 2S is the isentropic process. Okay, so 2S is the at the isentropic condition. Okay, and T2 is the actual condition. Okay, so 1 to 2, you know, you can see in the graph, if you can see, when 1 to 2S we go, your S is constant. Okay, and S is your entropy. Okay, so 1 to 2S is your isentropic process. Okay, and when 1 to 2 if you go, that is not the isentropic process, that is the actual process. Okay, so that's the thing. Okay, so that's the reason why if the isentropic efficiency is 100%, instead then there is no role of your T2. Okay, the graph is straight, directly 1 to 2S, there is no 1 to 2. Okay, so okay, now we are finding our pressure ratio. your T2s divided by T1 is equal to Rp to the power gamma minus 1 by gamma. So what is Rp? Rp equal to T2s by T1 to the power gamma by gamma minus 1. What is T2s? $335.56, and T1 you already found out, 295. Okay, and what is gamma for air? 1.4. 1.4 minus 1.4. If you solve it, you get Rp as 1.56. Okay, this is the first bit answer. Now the third bit is inlet angle of the vanes at the root and tip of the impeller eye. Okay, so now how U1 will be found out? U1 is your pi D1 n divided by 60. Okay, so pi into what is D1? It's already given in the question. D1 is 15 centimeter, which is your eye root diameter. Okay, so 15 centimeter means 0.15 meter. What is n? 15,000 rpm divided by 60. Okay, so if you solve it, you get U1 as 117.75 meter per second. Okay, so what is theta? Okay, theta is the vane angle at root, and phi is the vane angle at eye. Okay, so we need to find out theta and phi. Okay, because in the question it's asked what is the inlet angle of vane at the root and tip of the impeller. Inlet means your 1. Okay, at the root and tip means root is your what? Theta. Okay, root is your theta and tip root and tip is your phi. So theta and phi we need to find out. Okay, so already shown in the figure also. You can see theta and phi. Okay, so what is the formula? Okay, simple. We can apply the simple trigonometry here. Okay, tan theta we can apply. Okay, so what is tan theta? So if you apply tan theta equal to what? V1 by U1. From this triangle you can see the bottom triangle, you can see tan theta equal to V1 by U1. Okay, Okay, what is V1? Already we found, already given in the question, that is 150. You see, it's given, not here, here. Yeah, in the question it's mentioned. Assume that the velocity of air at the inlet is 150 meter per second and is axial and remains constant across the eye of the annulus. Okay, it's already given. V1. So B1 divided by U1. What is U1? U1 now we found out 117.75. Okay, so when you do it, and you have to take the tan inverse. So theta is equal to tan inverse of 150 by 117.75. If you do it, you get the theta as 51.86 degree. Okay, this is also your answer. Third bit. Again we need to find out the hour, what, phi. Okay, okay, one more thing we know is that, okay, phi s. What is phi s? Phi s is your 0.9. And what is phi s called? It's the sleep factor. How this sleep factor is related, that we first see. Okay, okay, the sleep factor related to your BW2 and U2. Okay, sleep factor is the ratio of BW2 and U2. Okay, so sleep factor phi s is equal to BW2 by U2. Okay, this is the formula. So we don't know what is BW2, so equal to phi s into U2. What is phi s? 0.9. What is U2? U2 already we found out, 235.5. Okay, so we get the BW2 as 211.95 meter per second. So now you have BW2. Okay, why we need to find out BW2? Because when you apply trigonometric function of phi, tan phi is equal to, what will be tan phi? The tan phi is equal to your height is your what? BF2. BF2 divided by this value will be what? U2 minus BW2. Okay, so tan phi is equal to BF2 divided by U2 minus BW2. Okay, that's the reason we need BW2 first. That's the reason I find out from phi s. Okay, so this is equal to BF2 divided by U2 minus BW2. Okay, what is BF2? Already I told 150 equal to B1 is equal to BF1 equal to B2, sorry, BF2. So that is equal to 150 divided by U2 235.5. BW2 now we find out 211.95. Okay, so phi is equal to tan inverse of this term 150 235.5 to 11.95. So when you solve, you get the phi value as 81.07 degree. Okay, this is your answer of the third bit. Okay, so now this question over. One more question we will solve, then we end the section. There are two types of question can be asked. First question is related to the angles, and the second question can be this type of question related to your cycles. Two types of question from centrifugal compressor can be asked as the short question. Okay, this type of questions are the second type. Okay, a gas turbine utilizes two-stage centrifugal compressor. The pressure ratio for the first and second stage are 2.5 and 2.1 respectively. The flow of air is 10 kg per second. This air being drawn at 1.013 bar and 20 degree Celsius. If the temperature drop in the intercooler is 60 degree Celsius and the isentropic efficiency is 90%, for each stage, calculate the actual temperature at the end of each stage and the total compressor power. Okay, this is the question. Okay, when this type of questions come, first you have to draw the cycle. Okay, so only here up to this is we are not required to draw here the full cycle. Okay, here half cycle is also enough. Okay, that means which person we are required to find out. Okay, because it's related to one kind of device, maybe compressor, nozzle, or like that. Okay, if there is directly mentioned in the question it's a Otto cycle, Brayton cycle, like that, then you have to draw the full cycle. Okay, so this is your TS diagram. Okay, so here one in the question one thing mentioned is that here one intercooling two-stage centrifugal compressor is there. Okay, mostly everybody knows what is single stage centrifugal compressor, that is the normal one. Okay, that means here one staging is there. Okay, and staging in terms of what? In terms of first stage some pressure ratio, second stage some pressure ratio. Okay, that means different pressure ratio are involved. Okay, that means different pressures are involved. Okay, so pressure ratio means there will be at least two pressures will be there. Okay, and how the pressure lines looks like in the TS diagram, it will look like this. Okay, like this will be your pressure lines in the what? TS diagram. Okay, so that means there will be four pressures will be involved in the question. You can get to know because two stage, so each stage having two pressure, so total four pressure will be involved. Okay, or because here you see one other things also mentioned is that here the it how it's connected, how these two things is connected through a intercooler. Okay, intercooler having the temperature of what? 60 degrees Celsius. Okay, so how we attend this question is that, okay, so that means what does it mean? That here only instead of 4 pressures, there will be 3 pressures will be involved, and 1 pressure will be what? Common. Okay, that is the real how you attend the question in kind of staging question. Okay, first stage, second stage, like that. Okay. Okay, so I just draw it so that it will be easy. Okay, so this is your P1 T1, this is your P2 T2, P2 is your common pressure. Okay, then this will be your also, this can be P3, but the P2 and P3 will be same. 4 pressures involved, but P2 and P3 are same. So here we also write down P2, but temperature will be different. Okay, because it's having some less temperature, T3. Okay, so and here it will be what? P3, and temperature will be also different. Okay, so total 3 pressure involved and 4 temperature involved. Okay, in this type of question. Okay. Okay, so what is the things given? First of all, we write down. First, always remember, always in the cycle, so the direction. Okay, so that's what the thing. So what are the things given? M dot is equal to 10 kg per second. Okay, so now 2 pressure ratio. First pressure ratio P2 by P1 always 2.5, and P3 by P2 will be your 2.1. Okay, so how you know where to choose the first and where to choose the second? Okay, how it's in the question mentioned, like that you have to proceed. Okay, and it's written in the gas turbine. So gas turbine, the cycle will go in the clockwise direction, 1 2 3 4 in the clockwise direction. Okay, so and it's written first stage. The first stage obviously in the what? Right side. That means P1 to P2 will be your right side, and left side will be your P2 to P3. That is the second stage. So like that you have to means go through this question. Okay, first will be P2 by P1, then P3 by P2. Okay, so and then what are the again things given? P1 also given. (101.3 kilos Pascal), because 1.013 bar given. T1 293 Kelvin. Okay, some temperature drop given. Temperature drop in the intercooler, where this intercooler play into existence. Okay, intercooling means what? That's the reason I already told why this pressure is constant. P2 from T2 to P2 from T3. Why it's constant? Because of what? Intercooler. Okay, in the question it's mentioned intercooler at 60 degrees Celsius. Okay, and in intercooler the pressure always constant. Okay, that's the reason why there is only 3 pressure. So what is the difference given? T2 minus T3, 60 degrees Celsius, and isentropic efficiency also given as 0.9. Okay, isentropic efficiency of 0.9 it's given. Okay, isentropic efficiency 90%. Okay, next what you do? So okay, so one thing we should here also, because isentropic efficiencies are given, so here one thing we have to mention, okay, the actual processes. Okay, so this will is not your T4, okay, it will be different. Okay, this is your T2 and this is your T4 and this is your T2S, this is your T4S isentropic. Okay, you can write down it very well. Just remove it. Okay, okay, T2 and T4. Okay, so now because this 1 2 to 3 is the isentropic process, so 4s will be the case. Okay, similarly 1 to 2 is the isentropic and T2 will be your actual, 4 is the actual. Okay, so and here you should note that in the question it's written difference means don't take the isentropic difference, or it's the actual difference, T2 minus T3. Okay, so now go to the solution. What will be your T2S? T2S will be your T1 into P2 by P1 into gamma minus 1 by gamma. Okay, what is T1? 293. What is P2 by P1? 2.5 it's given. Then 0.4 by 1.4. Okay, so when you solve, you get T2S as 380.68 Kelvin. So now you have T2S. That means now you have to find out what? T2. So how you find out? Isentropic efficiency. Same approach. Okay, but here there is no triangles given. There only triangles are given as different velocities. Okay. T2S minus T1 divided by T2 minus T1. Okay. So T2 equal to 293 plus 0.9 T2S minus T1. T2S is your 380.68 minus 293. So what is your T2? 390.43 Kelvin. So now you get your T2. Okay, we know the difference T2 minus T3 what? 60 degrees Celsius. Okay, Difference does not matter, is it Celsius or Kelvin. Okay, so T2 minus T3 equal to 60. 390.43 minus T3 is equal to 60. So what is your T3? 330.43 Kelvin. Okay, so now you have T3. So you have now T2, T3. Now in next cycle we have to go T4, T4s. Okay. So what is T4s? Same formula. T3 into P3 by P1 sorry P3 by P2. Okay, gamma minus 1 by gamma. Yes, correct, yeah, it is divided by 0.9. Yeah, correct. Okay, so yeah, because T2, yeah, correct, yeah, the answer is anyway correct. Because I solved. It's divided by 390, but if it is T2s, then that will be the case. Okay, so T2 is here 390.43. Okay, so similarly we can do it this thing. You can now directly write down what is T3. Yeah, so T3 is here 330.43. P3 by P2 is here 2.1, 0.4 by 1.4. Okay, so answer will be 408.45 Kelvin. Okay, so this is your T4s. In the same way, you can find out T4 is equal to okay, so T4 is equal to what? T3 plus T4s minus T3 divided by 0.9. Okay, so T3 is here 330.43 plus T4s 408.45, T3 330.43 divided by 0.9. So what is your T4? 417.12. Okay, so now T4 we get. Okay, why we are doing all this thing? Because we have to find out the what? Compressor power. Okay, so actual temperature we now find out at each end of each stage, that is what? T2 and T4. Okay, so at the end of each stage means it will be your what? T2 and T4. Okay, so T2 and T4 will be your answer. Okay, this is your first bit answer. So now we can find out our compressor power. Okay, so what is the formula for compressor power? Okay, compressor power P is equal to, here if there is only one cycle, then it will be what? If 1 to 2 will be the only cycle, then mcp into t2 minus t1. Okay, so now there is two compressor are involved. Okay, staging is there. Okay, so staging will improve the efficiency of the compressor. Okay, so staging always will be what? Added. Okay, not subtracted. Okay, so it will be, you can write down there. PC, let it be mcp t2 minus t1 plus T4 minus T3. Here you see all the temperatures is required, 1 2 3 4, all the temperatures. If you don't know all the temperatures, then we cannot find out the compressor power. Okay, so this is your 10, .005, T2 390.43, T1 293 plus T4 417.12 minus 300. Sorry, 330.43 na? Oh, yeah. Okay, so if you solve all this thing, you get the compressor power as 1850.406 kilojoule, because 1.005 in what? Kilojoule per kg Kelvin given, so the unit will be 1850.406 kilojoule. Okay, okay, I think with this we can end this section. Okay, thank you very much for attending the section. Okay, if you have any other doubts, you can ask me in my YouTube channel Sumit Sagar Hota, and you can ask also question in NPTEL question and answer forum. Okay, thank you very much for attending the section. We will meet next week again 6 to 8. Thank you very much for attending, and good night. Okay.